Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on polynomial zeros and multiplicities. So overall, it's going to be super important and super helpful if we know roughly what the function or equation we're working with is going to look like when we graph it out. And it's super important that we're able to quickly and efficiently identify certain characteristics of those functions. And that just allows us and enhances our ability to familiarize ourselves with that specific function. And so that's what we're going to be working on today, identifying those characteristics like y-intercepts or end behaviors or x-intercepts very quickly. And we're also going to introduce this idea of multiplicity. Okay, so let's get started. Let's look at this first problem. So we're asked to sketch the graph without a calculator using the x-intercepts and direction of the graph. So let's draw our x and y axis right here. Okay, so first, what I'm going to do is we have this in intercept form, this quadratic in intercept form, so we can readily see our intercepts. They're just going to be the opposite of whatever we're subtracting or adding. So essentially, we want to set this first parentheses equal to 0. That means x would be equal to 5. So I'm just going to put an intercept or a point right there. And also, we want to set this parentheses equal to 0. So this x is going to be equal to -1. So I'm going to put that right there. Now what I'm going to do to help us is I'm going to switch to standard form. And this is where being able to manipulate your polynomial functions comes in handy. So we want a FOIL. So we're going to multiply this x by this x, and we're going to get x squared. This 5, or -5 times x, we get -5x. But at the same time, we have -5x. I'm going to keep that in my head. We're going to do this, and we get plus x. So -5x plus x is going to give us -4x. And then we have -5 times 1, so that's just -5. So our y-intercept is just going to be this value. So we're going to have a -5 down here. Okay? And so roughly from here, I know it's a quadratic, so I know it's going to be a U-shape. But I also know that there's a positive leading coefficient. And so a quadratic is has an even degree, so we know the end as x approaches -infinity and positive infinity, f of x is going to approach the same direction. So either both positive infinity, both negative infinity. That just means either it's going to be going down like this or going up like that for both. And then, so that means since it has a positive leading coefficient, it's going to go up in both directions. If you have any questions on my logic for that, I would go and look at the last video on end behavior. But it's going to look something like that, roughly. We don't need exact values for every single point. We just want to get a rough idea of what it's going to look like. Okay? And using different strategies to help us get there. Okay. So here, let's graph again. In this case, again, we have it in intercept form. So we want to set this parentheses equal to 0. We get -4. And here, we'll get +3, so something like that. And then we have a negative. Again, this is a quadratic, so we know it's ending in the same direction. But we have a negative leading coefficient, so it's going to open down. So I know it's going to eventually go something like that. Actually, I'm going to keep that in my brain, but I'm going to first find the y-intercept by foiling it out. And I'm not really going to go over every single step because hopefully we're pretty comfortable with factoring as it is right now, but it's going to be something like this. Should be something like that. So all the way up here. You know what? I'm gonna totally redo this graph because I had this out of scale. So we're still gonna have, we're still gonna have this, our x and y axis. We're just gonna sort of change the scaling. So this is gonna be -4, this is gonna be +3, and our y-intercept is gonna be +24. So it's gonna look something like that. It's gonna be relatively steep because we do have this 2 out in front, which vertically stretches our function. Let me just make sure this is correct. Okay, yeah, should be good, perfect. Okay, now we're given this quadratic again. And so maybe what we can do is first, we can easily identify in standard form our y-intercept, which is going to be 9. So I'm going to put that here. And now I'm going to factor this. And I realize, oh, it's actually, I can make it into a binomial squared. It's equal to x minus 3 squared. Oops. X minus 3 squared. So I know that our our x-intercept is at +3. It's at +3 twice. So we only have those 2 points. We know that we have a positive leading coefficient, so we know it opens up. So we know, right? Also, one thing we can do is we know that this is our, this is going to be our vertex, right? Because since we have, one thing is when we have this in intercept form, so in a form like this, or I can even consider this an intercept form if I just say it's x minus 3, I know that since parabolas are perfectly symmetrical, the midpoint between those two intercepts is where our vertex is going to be. So in reality, like, this is not graphed perfectly, but its vertex is going to be slightly to the right at about -0.5. But here, since our two x-intercepts are one x-intercept has a multiplicity of 2. We'll talk about that in a second. Sorry, I'm getting a bit ahead of myself. It's basically right in between, so it's right on. I did not explain that well, but hopefully you get the idea. It's symmetrical. So I went on an entire tangent, but let's just find another point so we get another idea. Let's plug in like 4, for example. If we plug in 4, we get 4 minus 3 is 1, 1 squared is 1. So we have 4, 1. It's going to be something like that. I don't know. So it should look something like this. Again, this is just a sketch. Right, they're saying sketch. So it does not need to be perfect, okay? Great. So let's, some important characteristics we should remind ourselves of when we're graphing functions like these. It's to find the zeros and x-intercepts, also known as the roots, to find the y-intercepts, to factor if needed, which we did up here, plug in x equals 0, which we could do in all of these cases. I just converted them to I converted them to standard form and just found the c value. And we can also solve for x when y equals 0. And that helps us find the x-intercepts. And we can also use end behavior, which we said if it's even and it has a positive leading coefficient, we know that they're both going in the same direction, both positive. So I'm going to say even positive coefficient, I'm just going to say positive and positive to just signify they're both going up. And if it's even negative coefficient, they're going down to negative infinity in both directions. If it's odd and it has a positive leading coefficient, then that means it's going to be going negative and positive. As it approaches negative infinity, f of x is going to approach negative infinity. As x approaches positive infinity, f of x is going to approach positive infinity. For odd with a negative leading coefficient, it's just going to be the opposite. If you have any questions on any of this, look on the last lecture on end behavior. Okay, now we're introducing something new here, and that is multiplicity. So essentially, this basically means when we have a function that looks like this, what we have for f of x right here, that looks super complicated. And if we're trying to find the x-intercepts, we just set each of these parentheses equal to 0. And so we'd get x equals -3 here, and x equals +2, and x equals -1. But notice that for some of these parentheses, we're squaring them and cubing them. So for example, when we just have it to the first, which we have right here, this first parentheses, we're just going to go straight through, something like this, okay? And we see that here, right? For -3, we just go straight through it. But for something like this second parentheses, where we have x minus 2 squared, we're going to bounce. So here, we bounce off the x-axis. So we look for 2 here. Notice that we bounce. For x plus 1 to the third power, so now we have a multiplicity of 3 since we're raising it to the third. We're going to drag. So notice that we drag here. So when we have a multiplicity of 1, we go straight through. Straight through. If we have a multiplicity of 2, we bounce. If we have a multiplicity of 3, we drag. Okay, great. So now let's sketch the graph of y equals x minus 3 squared times x plus 5 using some of this information we just learned. Okay, so let's graph our x and y axis. So for example, we're asked about multiplicity in these first 2 bullet points. So we first want to set this parentheses equal to 0. So x minus 3 equals 0. That means x equals 3. And we have a multiplicity of 2 since we're squaring that parentheses. Now here, for this second parentheses, we have a 0 of -5. And we have a multiplicity of 1 since we're not raising this parentheses to any exponent except for 1. So let's put that down real quick. We have a 0 of 3, so I'm going to just put something there. But we bounce, so we bounce because we have a multiplicity of 2, so let's just keep that in mind. We also have a 0 of -5, so something there. where we have a multiplicity of 1, so we go straight through. Okay? Now let's fill in some of these other points. So degree, what's our degree? Well, that means it's basically our highest degree. So how we do that is we square this x, since we're raising this entire parentheses to the second power. So we have x squared, and then we'd multiply by x again. So we'd eventually have x squared, like essentially assume we FOIL this entire function, right? It'd be super complicated and it'd be a little bit of work, but eventually we'd get a term where it's x squared times x, which is just equal to x to the third. So our degree, our highest degree, is going to be 3, and we're going to have a leading coefficient of 1, which is going to be positive. Okay, hopefully that makes sense. I'll show you a little bit more about that idea in future problems. But essentially this means, since we have an odd degree and a positive leading coefficient, that means our end behavior is going to be, as we approach negative infinity, as x approaches negative infinity, f of x is going to approach negative infinity. And as y approaches positive infinity, f of x is going to approach positive infinity. And our y-intercept, we're just going to plug in 0 for x. So we get 0 minus 3, which is negative 3. Negative 3 squared is 9. 0 plus 5 is 5. So 9 times 5 is 45. And, I'm going to write 0, 45. And this probably, by the way, this probably is not the notation you should put. You might want to say, maybe you want to be super specific and write out fully, as x approaches x arrow negative infinity, f of x arrow negative infinity, and then do it that way, and do that for as x approaches positive infinity too. That's probably the more correct way. I'm just going pretty fast here. Okay, so I'm going to write down our end behavior right now. I'm going to do something like that. And I'm also going to do something like that. That's our end behavior here. We talked about zeros, and we also have a y-intercept of 0, 45. So something... You know what, let's actually just scrap this entire thing, just because we need to change the scale again. So here we have a 0 of negative 5. Just going to draw that there, and a 0 of positive 3. And then we have a y-intercept of 0, 45, so something way up here. And we have something, we know our end behavior goes like that, and also like that. So now we just want to connect the dots. For our 0 of negative 5, we have a multiplicity of 1, so we're just going to go straight through. That is not a good graph. I'm sorry. Oh, sorry, this is not super good right now. My bad. So it's going to be something like this here. But we have to go down to get that 0 of positive 3. So we're going to go down here. Now, what's the multiplicity of that 0 with positive 3? That's 2. It has a multiplicity of 2, which means we're going to bounce. So we're going to touch 2, and then we're going to go back up, and it's going to look something like that. Hopefully that makes sense. From this, we can just get a rough idea of what this graph is going to look like. And it looks pretty complicated, but here we're able to sort of digest it somewhat easily. Okay, let's fill all of this out first, and then we'll start graphing, okay? We learn from our mistakes. Okay, so first we want to find the 0 for this first parentheses, so that's going to be -4. We're not raising it to anything, so it has a multiplicity of 1. We're raising it to 1. Okay, I just need to put that in there. Now, for the second parentheses, we have 0 of +1, and we have a multiplicity of 2 since we're raising it to the second. And for this third 0, we have a 0 of -2, and we're raising it to the third power, so we have a multiplicity of 3. Here, essentially, maybe this might be a better way to do it. Think about all the x's and what they're raised to, like what their parentheses, what exponent their parentheses is raised to. So for example, in this first problem, we had a parentheses raised to the second and a parentheses that's technically raised to the first. So we add 2 plus 1 and we get a degree of 3. We can use that here. So this is sort of like an invisible 1. We add 1, 2, and 3, we get 6. So we get 6. And just be mindful that if maybe there isn't like an entire parentheses, but there's just like an x, be mindful that that would be an x to the first, and you would have to include that too. So we have a degree of 6, and we have a negative leading coefficient because we have this negative sign out front. So our end behavior, since we have an even degree with a negative leading coefficient, is going to be negative, negative. And our y-intercept would just be plugging in 0. So we do 0 plus 4 is 4. And 0 minus 1 is -1. -1 squared is 1. 0 plus 2 is 2. 2 to the third is 8. So now we do -0.5 times 4. And sorry, I'm just doing this all in my head. I don't really want to write this down. Slow it down and rewind and write it down on paper if this is not making sense or I'm going too fast. But -0.5 times 4 is just going to be -2. -2 times 1 is just going to be -2. And -2 times 8 is going to be -16. So our y-intercept is going to be 0, -16. Okay, now let's try to graph this. Let me just make sure. Okay, maybe something like that should work. Okay, so we have a 0 at -4, -2, and 1. Then we have a 0 all the way down here at 0, -16. Or sorry, a y-intercept. I don't know if I said 0. Okay. So we also know that our end behavior is going down in the negative direction towards -infinity in both cases. So we want to go up here. For our 0 of -4, we have a multiplicity of 1, so I'm going to go straight through. I'm tripping, sorry. Go straight through. And then we need to go back for the 0 of -2, which has a multiplicity of 3. So we're going to have to go down. And since it has a multiplicity of 3, we're going to drag. We drag like that, and now we have to go down to reach this y-intercept. And then we have to go back up to reach that 0 of +1. This isn't the best graph. And then we have to bounce since we have a multiplicity of 2. Something like that. That is actually a horrible graph because we can't go back here. But hopefully you get the idea. And also, one thing I will say is this is just a sketch. It doesn't need to be exact. You just need to get the major key characteristics of certain graphs included. And also, when we have certain points like this where we have a y-intercept here, it may not turn around exactly at that y-intercept. It may just go through and then turn around right here, okay? And as for Algebra 2, we don't need to know exactly where it turns around. It's just whatever sort of makes sense to you. In calculus, once you learn derivatives, you'll find a better way to find exactly where that rate of change turns from negative to positive. But that's outside of the scope of this course right now, okay? Let's practice a couple of these, okay? So first, let's just graph, you know what? No. Let's graph this in black, okay? Perfect. Now we have zeros at positive 5 and negative 2. We have a y-intercept of when we plug in 0, we get 0 minus 5, negative 5 squared is 25, 0 plus 2 is 2, 25 times 2 is 50. I'm just gonna have to keep on changing these, this scale. I'm sorry, everyone. Okay, so we had a 0 of 5 and negative 2. And a y-intercept of 50, something up there. And we know, well, let's talk about the degree. This is essentially like x plus 2 raised to the first power. So 2 plus 1 is 3. So our degree is going to be 3. And we have a positive leading coefficient. I'm just writing this down, thinking out loud. Yeah, so we have an odd, this is an odd degree and a positive leading coefficient. So that means we're going to end up going down and then up. So I'm going to graph, I'm going to go down here, or down here. And then I know at our 0, at x equals 5, we're going to have a multiplicity of 2 since we're squaring this, which means we're going to bounce. So that's what's going to allow us to go back up here. So let's just connect the dots. I need to redo that, I'm sorry. It's so bad. Perfect. Great. Okay. Now let's choose something that looks a little bit more complicated. Let's choose, you know what? Let's choose 5. Okay? Because we're going to factor this and we're going to use something we learned pretty recently, factoring by grouping. So I did a lecture, I believe it was 2 classes ago, on factoring by grouping. And essentially what we're going to do there is we have these 4 terms and we want to factor out the greatest common factor from both of these terms. So we're going to have g of x equals, and what's the greatest common factor of x cubed plus 8x squared? That's going to be x squared. We're going to have 8 plus x, or sorry, x plus 8, same thing. Now here, actually, if we zoom in, instead of, essentially what I'm going to do is I'm going to say plus negative, okay? So here, what's the greatest common factor of negative 4x minus 32? Well, that's going to be minus 4, and we're going to be left with x plus 8. So this is essentially going to be equal to x squared minus 4 and x plus 8. And here we can factor x squared minus 4 again into x plus 2, x minus 2, right, conjugates, which lose the middle term, and x plus 8. Okay, now it's easier to graph this since we have it in factored form. So we have all the zeros right here. So let's graph this. Maybe something like that. So first of all, here we can tell our y-intercept. Sorry, my bad. We have our y-intercept of -32. So I'm going to put a point all the way down here for -32. And we have 0 at x equals -8. So something there-ish. We also have 0 at x equals -2 and x equals +2, so something like that. And our degree, well, we have essentially invisible ones here. 1 plus 1 plus 1 is going to be 3, which is odd again. And we have a positive leading coefficient. Or one thing we can also see is sort of going in reverse. If we were to FOIL this out, we see this 3 right there, and there's our degree, okay? It's easier to see it there than here. But hopefully you understand how I got 3 for some of these previous problems by just sort of doing it in reverse, if that makes sense. Okay, and then we have a positive leading coefficient because essentially we just have a +1 out in front of this x cubed. So with a positive leading coefficient, again, this is actually the same case as the problem we did before, where it goes down, then up. So I'm just gonna graph this, and we have multiplicities of 1 for each of these zeros. So I know we go straight through. So it's gonna look something like this. We don't know how high this goes right now. We need calculus or a calculator to help us with that. But we just go through each of those points and all the way down to that y-intercept, and we get something like that. Okay? Sorry for some of the technical difficulties. So if you do have questions, please come to me. I'm happy to help and answer all of your questions. Also go to Mr. Whitaker or whoever your teacher is. Use the tutoring center, and Miss Gifford. Use your peers as well as the internet, because there's a lot of resources online available to help you. Okay? See ya. Thank you.